For years, Pluto was considered the mysterious ninth planet of our solar system. Then, in 2006, everything changed. Astronomers officially reclassified it as a dwarf planet, and to many people, Pluto seemed to lose its importance overnight. Once viewed as a symbol of the outer solar system, it suddenly became little more than a frozen object drifting in the darkness beyond Neptune. But science has a habit of rewriting old stories. Today, Pluto is once again capturing the attention of researchers around the world. Thanks to observations from the James Webb Space Telescope, combined with data collected by NASA's New Horizons mission, scientists are discovering that this distant world may be far more active and complex than anyone expected. Rather than being a lifeless ball of ice, Pluto appears to be a world with an evolving surface, a surprisingly dynamic atmosphere, and perhaps even a hidden ocean buried deep beneath its frozen crust. That possibility alone has transformed Pluto into one of the most fascinating objects in the outer solar system. One feature dominates almost every image of Pluto. A massive, bright region shaped remarkably like a heart. Known as Sputnik Planitia, this enormous basin stretches for hundreds of kilometers across Pluto's surface. It is covered primarily with frozen nitrogen ice mixed with methane and carbon monoxide. At first glance, it appears peaceful and motionless. But appearances can be deceiving. Scientists believe this vast plain is not simply frozen solid. Instead, the ice may slowly flow over time, behaving almost like an extremely slow-moving glacier. Over millions of years, this frozen landscape gradually reshapes itself, erasing old features while creating new ones. That discovery alone surprised planetary scientists. On Earth, glaciers require constant movement driven by gravity and changing temperatures. Finding similar large-scale ice movement on a world nearly 6 billion kilometers from the Sun challenged long-standing ideas about how active distant icy planets can be. Even more intriguing is what may lie beneath Sputnik Planitia. Several scientific models suggest that Pluto could contain a deep underground ocean of liquid water hidden beneath its thick shell of ice. At first, that idea sounds impossible. Temperatures on Pluto are cold enough to freeze almost everything solid. Sunlight reaching the dwarf planet is incredibly weak, providing very little heat. So how could liquid water survive? The answer may lie inside Pluto itself. Like many rocky worlds, Pluto contains radioactive elements trapped within its interior. As these elements slowly decay over billions of years, they release small amounts of heat. While the energy is modest, scientists believe it may be enough to keep part of Pluto's interior from freezing completely. If that is correct, a liquid ocean could still exist far below the icy surface. Although no spacecraft has directly confirmed such an ocean, multiple lines of evidence, including Pluto's geology and computer simulations, make it an increasingly realistic possibility. The implications are enormous. Where scientists discover liquid water, they naturally begin asking another question. Could that environment also support chemistry related to life? At the moment, there is no evidence that life exists on Pluto. However, liquid water is considered one of the essential ingredients for biology as we understand it. If an underground ocean exists alongside energy sources and the necessary chemical compounds, Pluto becomes another world worthy of careful investigation. Its surface also tells an extraordinary story. Images returned by New Horizons revealed towering mountains made of water ice, enormous valleys, fractured terrain, and enormous cracks stretching across the landscape. These features suggest Pluto has experienced geological activity much more recently than scientists once believed. Instead of remaining unchanged for billions of years, parts of the surface appear surprisingly young. Some researchers think the slow freezing and movement of a hidden ocean may have gradually reshaped Pluto from below, creating many of the unusual formations observed today. Every new discovery seems to replace an old assumption. A world once dismissed as frozen and inactive now appears capable of changing, evolving, and surprising scientists at every turn. And if Pluto can remain active despite its extreme distance from the Sun, what other hidden worlds might be waiting in the darkness beyond Neptune? If Pluto truly hides a liquid ocean beneath its frozen crust, one important question naturally follows. How could such a distant world remain active for billions of years? Scientists believe the answer may involve more than just radioactive heat. Pluto shares an unusual relationship with its largest moon, Charon. Unlike most planet-moon systems, these two bodies orbit a common center of gravity located in the space between them. In many ways, they behave more like a double-world system than a traditional planet and satellite. This gravitational partnership may have influenced Pluto throughout its history. As Pluto and Charon formed and evolved, tidal forces could have generated additional heat inside both worlds. Although these forces are much weaker today, they may have played a major role in shaping Pluto's interior during the early solar system. Another mystery lies above Pluto's surface. Despite its small size and intense cold, Pluto possesses a remarkably complex atmosphere made primarily of nitrogen, with smaller amounts of methane and carbon monoxide. As Pluto travels around the Sun, portions of this frozen surface slowly evaporate into gas before freezing again as temperatures change. This constant cycle creates a thin atmosphere that expands and contracts over time. One of its most beautiful features is a bluish atmospheric haze stretching high above the surface. Scientists believe this haze forms when sunlight breaks apart methane molecules, allowing them to combine into larger organic compounds known as tholins. These complex molecules gradually settle onto Pluto's surface, giving many regions their distinctive reddish color. Although tholins are not evidence of life, they are considered important building blocks in prebiotic chemistry. Similar compounds have been detected elsewhere in the solar system, making Pluto an intriguing laboratory for studying the chemistry that may occur on icy worlds. Pluto also belongs to an enormous region beyond Neptune called the Kuiper Belt. This distant zone contains countless frozen objects left over from the formation of the solar system more than 4 billion years ago. Most of these bodies appear quiet and inactive. Pluto is different. Instead of remaining frozen in geological time, it shows evidence of moving ice, changing landscapes, atmospheric processes, and a surprisingly complex interior. Its uniqueness raises an exciting possibility. If Pluto can remain active despite its extreme environment, perhaps other large Kuiper Belt objects also hide underground oceans or unexpected geological activity. Future space missions may eventually answer that question. Scientists have proposed orbiters capable of studying Pluto over many years instead of flying past for only a few hours. Such spacecraft could map the surface in far greater detail, monitor seasonal atmospheric changes, investigate the internal structure, and search for stronger evidence of a buried ocean. Some researchers have even imagined robotic landers that could one day analyze Pluto's icy terrain directly. Those missions remain decades away, but the scientific rewards could be extraordinary. Every new observation reminds us that Pluto is far more than a distant frozen world. It is a place where chemistry, geology, and climate continue to interact in ways we are only beginning to understand. Most importantly, Pluto teaches an important lesson about exploration. Scientific discoveries often overturn long-held assumptions. The world once dismissed as an insignificant dwarf planet has become one of the most compelling destinations in planetary science. There is still no confirmed evidence that Pluto hosts life, but its hidden ocean, unusual geology, and complex chemistry make it one of the solar system's most fascinating mysteries. As telescopes become more powerful and future missions venture farther into the outer solar system, Pluto will almost certainly continue surprising us. What secrets remain locked beneath its frozen crust? Could its hidden ocean still exist today? And what other remarkable worlds are waiting beyond the orbit of Neptune? The answers may be farther away than we can currently reach. But every new discovery brings humanity one step closer to understanding the remarkable diversity of our cosmic neighborhood.